Okay, here we go. Welcome. Welcome to Bruce Homer and Alex Stolyarik.
Yes, that's it.
Okay, he's lying to me, I can tell.
No, that's perfect.
VR is a promising yet under-researched tool for learning. Join them as they present ongoing research on functionality and utility and discuss steps for building the next generation of metrics for digital learning. Welcome, guys.
All right. Thank you. So yes, welcome to Data-Driven Theory-Informed Dashboards. You're in the right place. And I represent EcoSystemOne. So EcoSystemOne is a virtual reality collaborative learning environment where middle school students create stories and games, or what we call story games, together. They publish it on our platform, and they kind of play it and exchange it. All of that is synchronous. All of that is instructor-led and after-school enrichment curriculum. So a year ago, we were awarded an NSF research grant to study collaboration and further develop adaptive learning algorithms. And we partnered with Bruce Homer, who's a professor of educational psychology at CUNY, and Jan Plus, who is a professor of digital media and learning arts, learning science at NYU. And I'm proud to be part of this team. This is great, learning something new every day. Also, I have to say that Games for Change supported us in this grant, so thank you, Susanna. Awesome. So I'm going to go over sort of how the EcoSystemOne came about, and then Bruce is going to jump in and talk about the research itself. So we started back in 2017 in exploring collaboration in teens in analog mode. So before we went into coding or did anything in VR, we just wanted to run some tests and understand how middle school teens collaborate and create stories. We had them sort of embody virtual characters and with their imagination, so to speak, and project the environments on the screen, and they literally did that a bunch of times, and we learned how they create and share stories. So this is actually a carbon cycle study, and they did really great, developing essential questions and sharing that afterwards. We then developed a sequence of what would be like a template for a class or a sequence of classes or a whole course, starting with a subject intro, going into the brainstorming of how the science concepts would apply in this or that story, and then how they would create essential questions. We were very sort of inspired by Harari's book, and understanding that we all kind of live with stories and make sense of the world through stories. We went into like how do we do that in a period of 45 minutes, an hour, 3 classes, with assessment, with peer feedback, and that seemed like a lot. But we then basically started looking at what does VR afford us? What can we do with that now that we have that sequence? And we created an interactive table where students could embody characters, they could record and replay basically their stories real time, and we created a quiz maker. You see that, and we could publish the stories after the class, and they could look at them, play them. So we would say that there is a story behind every door. We created this virtual space where they could enter each other's stories and kind of share, comment, like, dislike, and also publish on YouTube. So let me see if that works just like this, right? Yeah, so this is the prototype of our virtual learning environment, which is very centric around that table that I was just talking about. This is where students enter and actually play, role play, and brainstorm and have these ideas that actually this is all animated, that they can then replay and be one-to-one in the environment inside the game. They can change environments, they can change different assets, so this is like a virtual maker lab in VR. This is just a quick replay. We could see what it's like to be on the table once they embody the character, then the classroom actually disappears, and you are like, really immersed in that environment. Let's see, so we also opened up, we wanted to democratize that platform and give it, to teachers, as much as possible, and we try to create a simple interface where teachers could load buttons, with some content that could be a sort of a refresher, this info in the beginning of the class, and then load some assets, and also create sample curriculums. So we opened up Universal Academy for our playground with classes, just to run and create curriculums and sort of flush them out and see how that would work before we give it to others. That basically also led us to even further simplification to actually have teachers run the classes from PC. Every kid wanted to be in VR, but every teacher wanted to be, outside and monitor it on mobile. So this is a multi-device platform, ended up being. This is like, you could publish the peer level creations afterwards and play it on mobile, etc. So the last thing that we did was a digital replay system. And this is something that we did for actual study of the dashboards. We could replay the classroom from any point in space and analyze this is like a diver type technology. We could see it from any perspective of a student and further analyze their collaborative behavior. And I think that Bruce will talk more about that. And with that, I'm just going to hand this over. This is going to play till the end, but please welcome Bruce.
Thanks, Alex. Test? Yeah, okay. That's great. So now I'm going to dive into the data, which is what I like to do because I'm a psychologist. Jan and I were very excited to work with Alex and the team at EcoSystemOne, in part because of the rich data that it's providing. And we got very interested in what we should do with these data. I'm going the wrong way. Sorry. There, okay. Actually, I just realized, hold on one second. I'm going to show a video, and Adam told me to make sure that I have the sound set to sorry, okay, it's all good. Okay, so we want to look at analytics of the learning process that was going on in the system itself. And so what are learning analytics? It's collecting, analyzing, reporting data about learners, their outcomes, and the context in which the learning is taking place. But before you even start that, you have to ask the basic questions of, what data can you collect? How are you going to analyze it? How do you report it? And what are you going to do with it? So it all comes down to, for what end? So why analytics? Why do you want to look at these data? A couple of reasons. You want to give students feedback so they can help regulate their own learning process. You want to give instructors some real-time feedback so they can intervene if they need to be, or they can see what's going on with their students. You also, instructors may want to use the data to go back and do some kind of summative assessment to see how the students did in the environment. And then ultimately, we wanted to build systems that are intelligent and smart and can see in real time what the students are doing and intervene and give scaffolds or give more data or whatever's needed to help the students along in the process. Okay, and so this is just a model that we've built, just talking about the process. So you have some sort of learning environment, some learning takes place, and that provides data. You got to think about what variables you want to look at. You can look at affect, so emotional, cognitive, motivational, social, cultural. These are all different variables that you might want to collect data on. And then that feeds into some sort of adaptivity. and then go back and change in the learning environment, and you get this cycle, and hopefully then you see improved learning outcomes. The question of then what do you do with that for the humans involved, the students, the teachers, you want to present this data in a way that's easily accessible and meaningful. So this is where this idea of digital dashboards come up. So this is an example of one. And there's different types of data that you can feed into that. I'm going to talk briefly about this. So for the most part, you just get a lot of times primary data, which is just raw counts, means, averages. How many times did a student speak? How many buttons did they click? How many posts did they make? That's what 9% of what we do, but I think it's too simplistic. We need to sort of delve deeper into that. So you can have secondary data where you're, let me actually log in. So this is an example of some primary data, single raw, and this is coming from the EcoSystemOne system where, I can't remember which is this, but let's say, that's how many times they're vocalizing, that's how many times they're grabbing something, and movement. So it's just raw data, and with the system, with the EcoSystemOne playback system, you can actually go through and see, okay, what's going on right here when they're kind of active, and see that. But that's just raw data, which can be somewhat informative, but we want to go deeper. And so secondary data are data where you're using two or more variables and do some simple calculations. So it could be including temporal or spatial. So how many actions per minute, how many number of utterances compared to the total group. So the group made 1,000 utterances and you made 500 of them, so you did half of it. And total time spent on tasks and so on. And so the next level, and this is where I think we ultimately want to be, but it's also obviously more complex, are multimodal data, where you're taking into account two or more variables, could be even more than that, and it's not just a simple average or sum, it's some kind of algorithm that's providing some meaningful theory-informed metric. So examples might be something like attention. So are you, like in the VR environment, are you actually looking at what you're supposed to be looking at? Are you, if you're watching a presentation, are you looking at the speaker, or are you staring off into space? And we can use the metrics in the system to look at if you're looking at the region of interest in the environment. Concentration, are you engaged in activities that are appropriate for whatever's supposed to be done at that time? Communication, are you listening, are you speaking over your collaborators, and so on. So I want to show a couple of quick examples of some of these. So this is some of the primary data, and you can just see what I'm calling high and low cohesion. So if you look at this little time frame here, you can see there's kind of like spaced out, so it's someone's doing something, and not speaking over one another. Whereas in the low cohesion, these kids, it looks like they're all doing something at once. So let's have a look. So I started looking at this level, and then I went into the video to see, okay, is our hypothesis correct? And this is from that little section from the low cohesion group. So, this was not a great moment for this group. They were just kind of like broke down a little. One guy's going around just, I'm skiing. Yeah. Yeah, they actually get their act together and end up producing a nice video. But this is, I'm picking on them here because this is a moment of clearly not a strong group cohesion. So here's a high cohesion where they're practicing one of their stories. That's how my friends and I play basketball. It's like, we're better with the Newton's laws than making the baskets. So, the point being, looking at the graph, if you go back, it actually is corresponding to like an example of when the group was falling apart or when the group was actually doing what they were supposed to. Ultimately, we want to be able to automate that, give the teacher a heads-up display, so if he or she is not there, they can say, oh, it looks like this group's having trouble, can wander over to the table and say, do you guys need a little guidance? And then the next step would be to actually maybe get the system itself to maybe pop in an intervention. So this is hot off the presses. We're trying to build some algorithms in to do the multimodal analysis. And this is something looking at whether or not the group is kind of cohesing together spatially. Just a quick aside, these are not actually visible for the students, but these are part of the analysis that we use when we're looking at attention in the system to see, are they paying attention? Are they looking at each other when they're interacting? Are they looking at the slides when they're being given information? But you'll see some, well, let me just click it. It's going to switch over. And what the system does is it knows who's in the group, and it's making, and the lines are not there for the students. This is just part of visualizing the analyses, showing how far away all the students are from one another. The next step for us will to figure out what algorithm works best for that. Will it be like a centering algorithm? What's the virtual center for the group, and how far are they away from that? Will it be some kind of average of how far they are from each student is from one another? So we'll try that. We'll go back, do human coding of it to see if the algorithm works, and then refining it until we have what's a good algorithm for the system, and then we'll be able to then build in some kind of feedback for the students ultimately. All right. So final thoughts on what's going on. With all this big data that the virtual environments and digital environments give us, lots of big potential, but there's a lot to consider. I think there's a lot, we need to think about the stakeholders. What are we actually going to do with the data? What's going to be useful for the students, the teachers, the system itself, developers, and work back or top down from that way is not just like, oh, we have a ton of data. We also need to, in thinking about the users, think about ways to reduce and present the data in meaningful ways, and that's where the dashboards come in. And so there's different types of data, the primary, secondary, multimodal, that all can feed in and be useful for that. The meaning of what's going on also depends on what the activities are. So that's part of the reason why you can't just look at it, the whole system or the whole averages. All right, okay. So for example, with what we just saw, if the kids are planning, then you want to see lots of talking. If they're getting all props in and building stuff, they may not be speaking, but that might be a totally appropriate visualization for what's going on during that stage of the learning process. So that needs to be taken into account. And finally, this type of work takes a lot of skill sets, and I'm just a shout out for this kind of university business collaboration, like the SBIR grant that we have supports. We, as a researcher at university, I know about learning, I know about how to analyze data, but I don't have the skill set to build something as complex as the EcoSystemOne system and sustain it. So that's, it's a great partnership, and we're excited to be part of that. And that's it. Thank you. Any questions? Yes.
Have you tried to measure anything other than collaboration, or is that the only metric?
In this system, we've measured some individual factors. Like it starts off actually just raw data about the individual. So how much are they interacting with things? How much are they moving about? How much are they speaking? And then we're actually trying to infer the collaboration from combining the individual data. Yeah.
I'm curious because we were trying to build something similar, but I think our problem is that you have a lot of raw data, and how you put it together can differ, and there's a lot of white noise.
Yeah.
So how do you deal with the white noise in between the kids like moving around, or like, kids in like, especially kids our age, like 8 to 12. There's a lot of times where they're just distracted. So how do you like make sense of the humanness of it along with the metrics?
Yeah, I mean that's a great challenge, and even if they're speaking, they might be saying something on task, or they might be telling a joke to their buddy and distracting them. So some of that, like with moving around, you might have to put a filter in and say, okay, we're going to assume there's 20% movement that's just fidgeting for 8 to 12-year-olds, and then look at movement above that. Otherwise, you might have to start looking at some sort of processing of what's being said at the time, like NLP or something like that.
Yeah, we're thinking about NLP. I guess from your research, have you found like suitable margins for error for?
Have we found what, sorry?
Like suitable margins for error, like you were saying, how like if they're fidgeting around.
Yes, but I think it's going to be system dependent. So, like in the VR system alone, there's a certain amount of movement they're going to do that's not even going to be picked up by the system. And I have my collaborator who's more the data expert.
So, thank you. This is actually exactly the question that we're also struggling with. And in principle, there are two approaches, right? One is if you have a large number of participants and you already have the observations for those, you should be able to train a machine learning algorithm to figure this out for you. But if you don't have large numbers of participants because you're still building the system, then what we chose to do is go into the video and do video coding. And so you employ video coding strategies where you say, instead of having the algorithm analyze, we analyze it with human eyeballs, and it's much more involved, but it gives you a very good prior to say, this is where we're going to start in our algorithms. And then we essentially do a bottom-up approach with that, and then once we have enough data, we add a top-down approach from the machine learning. So in the end, it's going to be a combination where the machine learning needs a training data set to label what is happening, and you can do that with the video coding, right? So that's what we're preparing for that.
Thank you.
I actually just wanted to say that that's the huge part of the grant went into the system replay, the interface, because that took a long time to actually build and recreate the entire classroom, where we could dive in and fly around and follow anybody and then actually do research. So, I mean, that class replay, that's huge. I mean, that really was a great effort to pull off. I'm sorry, yes?
Yeah, so does this also help with, sometimes what you're teaching itself might be problematic. Does it give insights into reflection on the material people are teaching, or is it mostly judging students' ability to collaborate, pay attention, and just go through and,
Right, so those are two different things. So we are building the replay system for not just the research and sort of the adaptive learning, that's the grant, but we also have it for teacher training. And that's a separate talk, I think, altogether. But so we're building a teacher simulator. I mean, obviously, we're interested in quick onboarding, because that's the important thing, is for teachers to just, boom, go into it and be able to do something that's complex fairly easy. And then, yes, the training simulator that we're creating with that as well as a separate thing, that does, replay moments where we want to talk about how this situation was handled, or how that situation, what did they learn, what not, what did we learn from this class, and et cetera. But that's a little bit different than the research part.
But are you asking if you can build metrics for looking at learning outcomes? Or?
learning outcomes, and also maybe suddenly as you're doing it, you pivot. Like, are you stuck now on a track? Like, they must learn this material this way.
That help us out. Like, we learned so much through replays, and we pivot. I mean, so we're creating curriculums, right? I mean, so every class is different. I mean, it's not like we have physics, we have biology, we have entrepreneurship. So my partner is also in the audience, and she's in charge of communicating with schools, and we're starting a new program with that. So I mean, they're constantly new content, that we're thinking about, and replay is a huge part of that. Yes, we learn a lot. But outcomes, so our priority was engagement and transfer. So we want to see students apply science concepts in different situations and being able to apply that, meaning that I understand that this is not just one instance of how things work, but hey, I can recreate that in another situation, because that's what transfer is. And I think that there are plenty of VR programs, there are plenty of physics labs that take charge of, the other stuff. But then the actual application of science, which is, I don't know, 21st century skill for whatnot, this is something where we come in, and this is our algorithm of story game making, where they create learning or co-create learning materials, so to speak, together for other groups to actually open the door, learn something else, and so this is like what's called inter-classroom collaboration. This is like Roy P's work. Going further, please.
So, hi, sorry, you guys, it's a time to move on.
They promised us that we can stay over.
That's okay.
Yes, a few minutes. We're farther than a few
Okay,
minutes
all
over
right.
at this point. But I would love for you guys to continue your conversation outside, or to also meet the speakers if you guys are going to be there this afternoon. Obviously, answer her question, and then thank you
we
guys.
have one more?
You can answer her question, and then thank you so much for joining us this afternoon. All right, did you finish her question?
Oh, yeah, I'm just going to say, I think we've gone on. But yes, but it's an empirical question to figure out how we would actually tap into that. And, it would depend on the system, and it'd be lots of fun to try. Let's try it. All right.
Thank you.
Yeah, thank you.